Hello and welcome back to my channel. We are going to look at this second example on MSTs. I would like for you to pause the video, read the question and come right back. This question is asking whether for a given MST, let's call it T, if we square all the edges, would we still have the same MST? That's what the question is asking. Let's start by getting a little illustration. So just illustrate subset of vertices. Let's call this as usual S, and we call this V minus S, and this is just some random connection within. And let's also say that this is our shortest edge. Let's call this shortest edge CE. Let's call it E. So the answer for this question is going to be true, and let's explain. So I agree that T must still be a minimum spanning tree for this new instance. If all the edges are positive and distinct, that means we have edges. If all edges are positive and distinct, that implies that we have edges EI less than EJ less than EK all the way to EN, E subscript N. The thing is, when you say something is distinct, it means you can actually order them in either ascending or decreasing order. And this is simply the ordering of distinct edges, where in this case, E subscript I is the cheapest edge. And this also means that this cheapest edge, or the cost of all the edges, since they are distinct, would be, let's call it CEI, CEJ, less than CEK, all the way to, this is less than CEN. Moving forward, this is the cheapest edge, the cost of the cheapest edge and the cheapest edge. And when you square positive numbers that are distinct, the cheapest or the smallest number will still be the smallest. For example, if you have a set of numbers 3, 4, 5, 6, 7, and you square this, 3 square is 9, 9 you have 16, 25, 36, 49, all that. When you square them, the cheapest square is the square of the cheapest number or the smallest number. So that's the same logic for solving this question. When you square, we are going to have CEI square less than CEJ square less than C, all the way to K. We'll still have all this cost in the same order. So this means that this, when we square the cost of the edges, is still the cheapest edge, which implies that this, let's call this diagram, this MST, this implies that T is still the MST. I hope you enjoyed this video. If you did, click on the like, subscribe, and I'll see you on the next example.